Hello, and welcome to another episode of Drof Dev. I might be a little out of it. If you can't tell, it is 12:03 a.m. and a few months after the last one. I honestly feel like a good update video is required, but in case I don't actually do that, essentially university was wrapping up, so it was difficult to put in much more work into the project. Although for the past about month, we've been working full time on Alchemy Punch, as it's now called. I think last episode it was still called Glyph Gates. We changed the name because glyph is hard to say and hard to hear. But anyways, I want to get to the point because otherwise we'll be here all night. I will anyways. I've been sick the past couple of days, so you're gonna hear that in my voice. You're gonna hear that in my energy. But the main thing that changed is that we set up a big scaling system. Now I won't go too much into it because it's really boring. But one of the more significant changes that I had was that now the texture size for like animations has like squared or something. And that means it actually takes a lot longer to compile, I guess, because Flash Develop needs to embed all that image information into what it's building, which makes sense. No noticeable performance decreases so far, so that's good. But as you might be able to tell, this scales to a 2:3 resolution, which is just a good base resolution you can stretch to. And I'm just drawing white borders on anything that's outside of it. This is just our crappy dev screen. But like I said, it's difficult to really point at what changed. Oh, one other thing is that I'll have to go clean project a lot more. In fact, I've got a macro set up just so it actually does it automatically whenever I press the F5 key, which is just what it would need to compile. And that's annoying and kind of concerning, but we're going to be okay, I think. But something I can't talk about tonight is the end of level screen. So it's a little animation, and I'll shut up and... Yeah, so that's what I've got so far. It was something tinkering about the past couple of days. The sickness has kind of slowed progress down. But yeah, so... this is the game over screen. It's actually probably going to look like what's in between levels, but essentially when you get points in Alchemy Punch, you kind of reach different tiers. So if you get like 100 points, then you're in like the bronze tier. If you get like 1,000 points, then you're in the gold tier, stuff like that. And so instead of seeing like, one number that's just like a number, you actually see a progress bar that fills up from like one tier to the next, kind of like levels. And so you go past one, you see the next one, the next one, the next one. So at the end of the game over screen, you kind of want to see, where you're at between these two tiers that you were at before. So what happens here is that first the two tier icons on the left or right, they slide in, and then this point bar appears. And it starts off with just the gray backgrounds, and it slides in very quickly. And then then the green bar fills up inside of this. And then after that's done, these buttons at the bottom, which right now are not scaled correctly, slide in from the bottom. This was... it's a lot of foundational work, but when you get around to it, it fixed a lot of things. So, the one thing I want to talk about today is how I did the sliding. So the thing with Adobe Air is that Flash has a tweening system, like within its program, and if you use Flash, then you can actually convert that to ActionScript without any dramas. But it uses the library that Adobe Air itself does not have access to. So, if you want to, basically, if you're not an animator, what a tween is you basically set like two positions for an object to be at. You would draw, like, here's the start, and then you want that to be where it ends up. So like this is the object, and you just kind of want, you basically want this to move over how many frames, so like X frames. I'm doing this with a mouse, so live with it, nerds. So a tween basically figures out at what frame, what position this little black dot should be at. And that's really simple for animators. Like almost any animation tool will have something really simple for you to do that in, where you can just say, okay, here's the start, here's the finish, and I want it to ease in, which means that it builds up acceleration. Or I want it to ease out, which means it builds down deceleration, whatever. So it basically has like a kind of smooth going in and out motion. The problem is that that's actually, like, buckling down to do that was pretty complex math. But don't worry, because I've got a pretty simple solution for you. It's called a sine wave. So I made a class called sine animation, and let's go to that, shall we? So it takes in all these variables, which are all relevant to what the sine animation is. So first of all, it's a class which basically, it's kind of a zombie class in that it doesn't actually exist. If somebody tells me that this is a bad practice, then I might believe them. But you know, I don't. Considering ActionScript is a pretty good junk, a garbage collection medium, this shouldn't be a problem. Because whenever I define sine animation, as you can see, it's actually a horrible example. But yeah, I just save it here, and then I can start that at any point with the start function. Yeah, that one. Anyways, so it just basically is like, okay, so we know where we're starting, which is just, it gets automatically, and it wants to know where we're going. It wants to know how much time it'll take, how much time it's been so far, what we're moving, and whether we're moving at the moment, and also what we do once we're finished moving. And this function variable is very important for this function variable is very important for you know, when I had like the thing sliding from the sides and then the level bar showed up. This is where this function kind of leads it to. So as a sine animation, I might suggest, I wrote this all myself, but it was actually like, it was hard to plan out, but when you get down to it, it's really simple, because you just use a sine wave. And a sine wave, if you don't know, is a thing that kind of goes like this. And your x minus 0 thing will be this, I think. So that's where the sine wave starts. And this will range between 1 and negative 1. And it marks along the side in intervals of pi. So this is pi, or pi if you want to say. Not 2 pi's. So this has the perfect ease in and out that we see here. And, you know, for an animator, this kind of wave is very basic and liquid. Like, it probably isn't going to look amazing, but it's more than enough for just a simple menu thing for us. And there are ways to tweak this too. I mean, it just gets into more and more complicated math of like scaling certain parts of the sine wave, but we haven't even talked about the basic sine wave. So all you really, because all this does is just is like, if we're almost there, we're about to go there, then go there. So you don't need to pay much attention to this. This, however, is where the meat happens. So first we use a variable called t, which is substitution for time. And really what we want is a value between 0 and 1, where 0 is the start of the animation, and 1 is the end. So that is just, we take our current time and divide it by the total. This means that if current's ever above total, it'll be more than 1, but hey, we've got this, so it doesn't matter. And that would mean that we'd be over on this, whatever. Cross that bridge when we get to it. Then pause, which is actually where, I'm reading it now, actually. I think it's the Y on this graph. Yeah, no it is. So, pauses, because this is in T's in time of the animation. This is pauses in position of the animation. So, we also want this to range from 0 and 1. So, we want 0 to be where we started, and 1 to be where we're finishing. So pause as a variable between 0 and 1 is going to need to be, first of all, we want, because we're, I guess a sine wave, I always forget whether a sine wave starts like that or starts like that, but it is one of those. And we take that and go into this little bar thing here. So the important part is that this plus, as I recall, is because if you look at what a sine wave actually does, a sine wave starts like this. Well, it has a bigger, but it starts going kind of at its max acceleration going down. If you add half a pi, then you actually go into this trough right here. So that's where we want to go. So that means that when this is going to equal 0, which is usually when which is when t is 0, it's going to be 0. So it's at the start of the animation. We will start in this trough. And then t times pi means that because t is going to range from 0 and 1, it's going to range between 0 and pi, basically. And which is helpful because between a trough and a peak is always going to be 1 pi. So that's handy in that when we get to 1, which is going to be our maximum, then pause will equal its maximum value, which for us is going to be so. And also, because this is going both below and above 0, we want to add 1, which counterintuitively means we subtract the sine wave. So we end up kind of going, like that, but above the curve. Now the thing is that because this ranges between 1 and -1, then our range is actually 2. Well, we don't want that, because we want it to be a variable between 0 and 1. So we just divide it by 2. Easy. So now our pause is going to be some percentage of the difference between our starting and destination. So then what we got to do is just look at this. So first of all, our starting position is a given. We're going to have that, and then we're going to add it to everything else. So pause, which is, again, between 0 and 1, we're going to add a certain percentage of the difference. So basically, when this is 1, which is going to be our final frame, then we just want the full difference, which means it's starting pause plus the difference between starting pause and destination pause, which is, of course, going to just equal destination pause. And that's all that's going on here. The reason I want to highlight this is not because it's complicated math, it's because it seemed like it was going to be complicated. When I had to map this out, I was like, oh man, it's like a graph, and it's like, gotta go up and down and stuff. And, this is probably pretty old hat for any experienced developers that are watching this, but if you're newer, don't be afraid of stuff like this, because when you dive into it, it may not actually be as complicated as you may have thought. All you gotta do, and what I'd always recommend, is find a graph that just looks like what you want. So what I did was I was just like, okay, I want something that eases in and out, and I know that sine waves do that. If I didn't, I probably would Google something, just do some research. And then it was just a matter of like, okay, how do I hack it into what I want? So the first thing I needed to do was I needed to move it over, which is, that's an easy step. I just add this half pi to the equation. And then it was like, okay, well now I need it to be jumped up 1, so then I just gotta add 1 here. And then it was, okay, now it's a range between 2 and 1, 2 and 0, so now I gotta divide it by 2. And then I knew I had a value between 0 and 1, it was like, okay, that could be a percentage of the difference. And something that was really important about this is that before, I was kind of using a stupid system. I don't know if I could find it. Actually, I can. Because I haven't gotten rid of it yet, because I'm not actually using this code anymore. That's a lot of code to not use. Actually, I'm going to reuse a lot of it, but ordinarily when I was sliding, it basically would be like, okay, we've got a flat acceleration and deceleration value, and we want to have a flat velocity in the middle of that, so it was like, okay, calculate at what point we should accelerate and decelerate so that we get to for accelerating our max velocity in the right number of frames, or for decelerating 0 velocity in the right number of frames. It was dumb. And the thing is, I would have had to done this for like practically everything. And with that menu, every single one of those objects that you saw had its own sign animation. I had to write this code once. This took less time, honestly, than it took to write this, and it was a one-size-fits-all. So yeah, as I said, there are options to change this. You can actually make it so that, and I will add functionality in the future, you can make it kind of not ease in or only ease out, or the other way around, and stuff like that. But I will cover that in a later episode, because this is already going longer than I expected, as it always does. I coughed a lot, so I'm hoping that I'll remember to edit that out. But yeah, let me know if you guys want to hear some sort of an update video. I might do it anyways, but it would be interesting to hear kind of feedback on the series and stuff like that. So leave a comment below. I'm definitely at a size where I can read it all, and I'll see you guys later. Thanks for sticking around. I'm about to cough. Oh no.